Hello, welcome back. I'm Jeff Eicher. Almost forgot my name there. And this may be the last video that I'm making in the 2020-2021 school year during the asynchronous distance learning COVID time. So bittersweet, more sweet than bitter, I think. But in this video, we're going to look at measures of spread. In the last video, we talked about the mean and the median, which are measures of the center of a distribution of data. Here, we'd like to know how spread out, how variable the distribution is. And we have certain statistics that help us assess the variability of a distribution. So let's take a look. Draw two dot plots, which would have the same center, but the first dot plot, the students were consistently close to the mean test score, for instance, but the second dot plot, the scores were all over the place. So let's draw a scale. Here's a scale, and let's say we go down to 50 and up 60, 70, 80, 90, 100. We'll call these test scores. And for the first dot plot, I'll do this one in blue with dots. So if they were consistently close to the mean, let's say the mean was 80%. Let's say we had, 7 students, just to make it an easy number to work with. So let's say here are the points. There we go, 1, 2, 3, 4, 5, 6, 7. So the scores vary from 70 up to about an 88. The most common score was an 80, and the average here, the median, would be 80. So we have that center. Compared to this distribution, the second dot plot, I'm going to use the same axis, but I'm just going to make the dots red. I'm going to kind of shift them above the blue ones. So if the scores were all over the place, but we need the median to be 80 still. So let's put an 80, and then how about we do something like this? 1, 2, 3, 4, 5, 6. We'll have the same sample size of 7. There we go. So in the first dot plot, we have scores that on average are close to the mean. Whereas in this one, it has the same mean or the same center as the blue dot plot below, but the scores are more spread out, or also known as farther away from the mean. So we would like to talk about a measure, a statistic, a measure of spread or a measure of variability, because if I just told you that this is my period 1 class and this is my period 2 class, if I told you, well, both classes had the same average on the test, you might think that they performed similarly on the test. But actually, period 1's average of 80, a lot of people got really close to 80. Whereas in period 2, there was way more variability, even though the average is still 80. So we would like to be able to communicate that with a single number, a statistic, that tells us if a distribution is spread out or not so spread out. So we have just that. We have a couple statistics actually. One of them is called the range. So let's look at some test scores here. The range is just the maximum score minus the minimum score. So for this particular data of 5 student scores, the minimum is 84 and the maximum is 96. So we would do 96 minus 84. That would be a range of 12. That would be a helpful statistic. In our previous example, the range for this set is about 15 to 20 points, whereas the range for this set of scores looks like 50 to about 100. So that's 50 points. So we'd say the range for period 1 is much smaller than the range for period 2. Now, the range you've probably calculated before, but there are 2 other statistics known as variance and standard deviation, which actually factor in all the numbers of the data set. The problem with the range is it's only really looking at 2 numbers. It's only looking at the minimum and the maximum. But what about all these other numbers in the middle here? So that's what this next statistic is going to do. To calculate the variance, we're going to do this process. First, we'll find how far each value is from the mean. I've provided the mean of 90 for those 5 scores. We're going to square those results, and then we're going to add all those up, and then we're going to divide by the number of values that we have, and that gives us what's called the variance. So let's calculate that. We need to find the distance each value is from the mean. So we're going to do 84 minus 90. We have 85 minus 90, the distance from the mean. We have 92 minus 90, 93 minus 90, and 96 minus 90. So those are the distances from the mean. That was the first step. The second step, we're going to square those distances. We square the distances because we want them to be positive numbers, and some of those would have ended up to be negative. So we square them. So for instance, the first would be negative 6 squared, 36, 5 squared, 2 squared, 3 squared, 6 squared. So that's what we get when we square all those. And then we're going to add those results. So we get 110, and then third step, we take that 110 and we divide by how many values we have. 110 divided by, there were 5 test scores, and we get 22. So that would be the variance. VAR is the variance of the distribution. So just to recap, we'd like to find an average distance a value is from the mean. So we found distances from the mean, we squared them, and then we found an average by dividing by 5. Now the only weird thing about variance is the units are weird. If our original units were like, a score of 84% on a test, because we squared the values, our units here would be 22% squared, which is very, very strange. I don't know what that means to be percent squared. So more than a variance, what we use is our last statistic that I'll introduce you to is called the standard deviation. And standard deviation is simply calculated as the square root of the variance. So we walk through that whole process, we get this 22, and we're going to take a square root of 22. We do that because now the units make a lot more sense. We're back to percentage, not percentage squared. So we get 4.7%. So we would say, on average, a student's score typically varies by 4.7 from the mean of 90. So some vary more than 4.7, others vary less than 4.7, but on average, a student's score is on average 4.7 away from the mean. What this standard deviation tells us is that if you had a dot plot that looked like this and all the dots were at the same exact values, they were all at 80, your standard deviation would be 0 because there is no variability away from the center because they're all at the center. The symbol that we use for standard deviation is S, is 4.7. Or you could just write SD or STDEV. There's different ways to abbreviate standard deviation, but usually S equals 4.7. So last question, let's rank, put in order the following 3 dot plots from the highest to the lowest standard deviation. So let's start with the highest standard deviation. The highest standard deviation would be the most spread out of these dot plots. Or you could think of it as the most variability from the mean or from the center. So taking a look at those, it looks like the one that's the most spread out would be this one. This second one would have the highest standard deviation. Now we could try to calculate it, but I'd rather you be able to visually discern which has the highest and the lowest. Now the top one and the bottom one, they look like they're both the same spread for the range. They're both kind of, a range of, looks like 3. However, notice that this one has more points closer to the center, whereas this one doesn't have as many points as close to the center. It actually has points that are farther away from the center. So we would say that the bottom one would have the lowest standard deviation, since the dots are all close to the center or close to the mean. This one would have the middle ranked standard deviation. It would be smaller than the second one, but it's a slightly larger standard deviation than the last graph. So as a try this, you'll have a couple examples like this where you get to try to order some dot plots and determine which has the lowest or the highest standard deviation. I hope that video was helpful as we talked about measures of spread like the standard deviation, the most common one, the variance, as well as the range. And the range you've probably learned before, but it is also a measure of spread. Thank you for watching this video, and thank you for watching all the previous videos in this long year of 2020-2021. See you next time. Thanks again.